Hello everyone, welcome to AI Anytime channel. In this video, we are going to look at synthetic test data generation. So most of you would have been working with RAG, the Retrieval-Augmented Generation, and you would have been dealing with, you know, like large text document, okay, or large data sets where you have, multi-context data. Now, how can you evaluate your retrieval systems or the RAG system that you have built? Now, to manually baseline these RAG systems are a mundane task. It requires a lot of efforts. So in this video, we are going to use Ragas to create or generate synthetic test data based on the context that you already have, based on the data that you already have, and that will help you in evaluating in your RAG system. Now, Ragas is eval's tool, evaluation metrics. Like you would have heard of different evaluation metrics, for RAG, for retrievals, for synthesizing the responses. When you talk about retrievals, you have distance-based evaluation metrics like cosine, Jaccard, Levinstein, Euclidean, blah blah blah. And you have, because these all falls under approximate nearest neighbor ANN algorithms, and synthesizing, when the LLM synthesizes the context, once it synthesizes the response from the retrievals, then you use different evals, both qualitative and quantitative. So that's where we have used Ragas that helps you evaluate RAG systems. Now you can use Ragas to generate good quality synthetic test data. So let's jump into it here, guys, and see how we can do that. Now, Ragas is an open source library, so you can use it. Now, to do that, first of all, we have to install a few things. I'm going to do this in Google Colab. So you can see I have my Colab open here. So I'm just going to do pip install, and we are going to use Ragas, and I'm going to use LangChain OpenAI. You can use Grok, you can use Anthropic, you can use any other uh, LLM providers if you want. You can do it locally as well if you have the compute. And I'm going to do sentence transformers. I'm going to use an open source embedding model because embedding, I don't want to exhaust my credit for OpenAI. So that's why I'm going to use BGE embeddings, and probably I'm going to show that. We've installed Ragas, LangChain, OpenAI, sentence transformers, XML dict, because we're going to just convert that. Now, once you are okay with that, what we're going to do is we're going to import few things. So let's just import it. So what I'm going to do is import OS, and from Google Colab, import user data. Now, Google Colab import user data, why I'm doing it? The reason being because all of my secrets keys are here. You can see Anthropic, Gemini, Grok, OpenAI, Runpod, Serpent, Tavili. So I have all of my key over here. So I need the access to that. So that I'm going to use user data dot. Basically, I'm going to set that key in env, and that's why I'm using it. Now I need pandas here. So import pandas as PD because I'm going to show that in a data frame. Now all the LangChain thingy. So from LangChain community, every open source thingy can be found in community module of LangChain. Document loaders. So I just want to use document loaders. And let's take a medical use case here. So for example, if you are doing biomedical literature or something, you're building RAG on top of it, then how you can generate test data sets. So let me just do PubMed loader over here. If you can do the same with Llama index as well. Okay. Now I'm gonna do from LangChain. We need embedding. So as I said, if anything is open source, completely open source. Grok is not open source, by the way. Don't fall into all those dilemma. Like they they made you available, right? They make things available through their data centers and servers. They make Llama 3.1 available. Same happens with Azure, GCP and AWS. All these open source LLMs are available in their model repository. The only thing which is completely open source, which is available directly on Hugging Face, okay, when it comes to a large language model. From LangChain community, okay, dot embedding. So I'm going to just do embeddings here, and let's use Hugging Face embeddings. Okay, you can see I'm using Hugging Face embeddings. Uh, and you can also use Hugging Face BGE embeddings, guys. It also has directly. So let me just do BGE. You can see it over here. Okay, it's by Beijing AI Academy, BAAI. It's one of my favorite embeddings model out there. Now I'm gonna just do from LangChain. The OLAMA and all are very new thing, guys. I mean, when I say very new, it compare that with sentence transformers library and all. Like they came up with nomic embeddings, they make it available and all. Uh, Llama CPP is the bedrock of Cobol, of OLAMA and C transform. I mean, I don't know, like a lot of others. Okay, LangChain community and not the camp community. Now let's have OpenAI. So from LangChain OpenAI, I'm gonna import Chat OpenAI. You can also use OpenAI. You can also use Azure Chat OpenAI. You can use Azure OpenAI with both all instruction based, and also the base model is available. Now the Ragas thingy. So from Ragas dot test, you have to use test set generator. So this is the module that we're going to use, test set generator, and I'm going to use import. That's right. And then from Ragas dot test set, and then you need evaluation. I don't know why it's not showing evaluations. It should not be evaluator. From test set dot evaluations, whatever. Okay. And then let's just get import from test set dot eva. I hope I spelled it right. It's not evaluation. It should be. Let me. You can do a directory as well. I think it's evolutions. Yes, excuse me, I was typing it right. Evolutions, and then you imports different evolutions. It provide you reasoning based, multi-context, simple, and whatnot. So what I'm going to do is simple and what next? Multi-context. You can see it over here. Multi-context, and then reasoning. Yes, reasoning. Ex Perfect, guys. We have our everything. Now let's get the OpenAI thingy here. So os.env. So I'm going to set that in environment, user data.get, and that's it. We're going to give the grant access here. So let's just give a grant access. Now I have to grant the access, guys, and that's why I'm granting here. Now once you grant the access, now let's go into first declaring the LLM for generating. So I'm going to call it data generation model or something. And you can use Anthropic, whatever you want. Okay, if you want to use, let's don't use Turbo. I want to use 4o Mini, the latest by OpenAI. So I'm using GPT-4o Mini. Here you can see that, and then I'm going to use Critic model. So Critic model, and in Critic model, I'm going to pass Chat OpenAI, and I'm not going to use GPT-4 same model. Like probably let's use the more capable for complex tasks, because we are going to use this to act as a critic model. So I'm going to use critic model Chat OpenAI model GPT-4o, and then I'm going to use the embedding model, which is BGE. So for that, I want to copy paste a code, guys, from LangChain. Okay. So I'm going to use BGE embeddings, BGE on Hugging Face. Just come here and copy this it. So just copy this, come here and just paste model name, and just let's make this embeddings. Now what we are doing, we are saying, okay, model name, we are using BGE small embedding model. You can also use the large one, but I think just for the demo purpose, small makes sense. I'm having CPU, I'm not using CUDA device or device CPU. I'm asking to normalize the embeddings, just normalization, true, and then just calling that function embeddings. And this will download, if you're running it for the first time, it will take a bit of time. Let's do that. Now let me define my loader thingy. So for the loader, I'm going to use PubMed. PubMed is a biomedical literature data repository, PubMed Central, where you can use to, like do a lot of things like, reading research papers, creating data to train something and whatnot. So I'm going to do is, you can see the model has been downloaded from Hugging Face. Now, PubMed COVID, let's use a word, for example, cancer. Now, if you want to find out, you want to build a RAG system on top of cancer, on top of mental health, top of ADHD, top of liver, whatever, you just give that word, and then you can specify a params called load max or something. You can see it over here. It's showing you load max docs integer. So I'm just going to do load max docs, And in the load max docs, let's keep it 5, but you can increase it depending on if you have what kind of credits that you have or what kind of model you are using. Now, when you do this loader, you can just do documents, pretty much straightforward LangChain code, loader.load. So let me just do loader.load. And here, when you print the documents thingy, when you print the documents thing, it says too many requests waiting for 0.2 seconds. Let it wait. Meanwhile, if it takes a lot of time, I will just walk you through my GitHub code because let me just try it out. Document right now, it will probably nothing is there. Okay, you can see here, right? We got it. So probably it took a bit of time to get that if because it's free, right? So when you hit this again and again, it might take a bit of time for the API because they would have some rate limits, from users. So you can see all the metadata over here. So title, standardization of scan protocols for RT-CT simulator from different vendors. And then it talk about cancer. So they're all cancer related biomedical literature. And I want to build a RAG on top of it. Now, if I'm building a RAG on top of it, how can I evaluate? How can I baseline? If you are working in an enterprise, the first thing would be asking your client that give me the question answers to baseline it so I can baseline, on top of your data. And if you are like have humongous data like in GBs, where it's very difficult to go and look at the context, look at the paragraphs and create questions for the testing. You can just give it to Ragas and it will automatically create it for you. And that's the agenda of this video. Now let me just move to the next, which is like creating a generator instance here. So let me just do that. So for the generator, I'm going to use test set generator from LangChain, and you can use the same for llama index. Now you can see test set generator, and then I'm going to use test from LangChain, and in from LangChain, I'm going to pass a few things. First thing is yes, data generation model, and then I'm going to pass my critic model. It missed the critic model. Did I define critic model or didn't I? Okay, let me just run this again. I don't know why it missed it, but and I'm going to pass my critic model here. So you can see critic model, and let's just run it. Now, once you run this, we have a generator instance. If you like, it will be an object or something. If you do that, you can find it out here. Max retries train timeout like 180, max weight 60, max worker. It gives you an inference params over here that you can look at in the generator, that instance that we've created. Now, you can have a distributions like if you distributions can be of three different types: simple questions, then multi-context where you have multiple context for a given question altogether, and then you can have the reasoning as well, and you can divide the distribution. I think it's the most important part of creating test or any kind of data, guy, that your data should be diverse. Your data should be really diverse in nature. Some of those should be complex, some of those should be simple, some of those should be multi-context, and so on and so forth, right? And that's what we're going to use here. So let me just do distributors, and you can see it's showing me, but it's a okay. Now you can see simple, but we have to give a number, guys. This is all wrong. Okay, let me just. This is not how to do it. So simple. Now in simple, we basically give a value. So you have to divide this in from out of one, so you have to define it. So if you have three classes like simple, multi-context, reasoning, you have to keep the value that the sum should be one. So how I'm going to do this is, let's keep simple as like more 0.6, and then I'm going to keep multi-context, you can see, and reasoning, how much is 0.6, 0.2, 0.1 or something. I want to keep simple more and multi-context 0.2 a reasoning one, because I don't want, because it will take time, guys. It has to do a lot of iterations. So 0.7, 0.2, 0.1, the summation becomes 1. So let me just run the distributors, and now you can just create the test set instance. So let me just create test set, have a variable, and then use generator dot generate with LangChain. You can see it over here. It has llama index and it has LangChain docs, and you can just pass the documents. You can pass the documents and the distributors. So how many you want, for example, how many data that you want, like sample. So let's give 5, or 5 iterations. No, documents, 5 distributors, and then you can just run it. Now once you run it, it will take a bit of time. So what I'm gonna do, probably let me also open my GitHub so I can just show you right there just to save some time because we are done with our code, guys. So I'll just show you here. Now this is what happens. I'll just make this a bit big so you can see it. I don't know what happened to GitHub. Okay, but anyway, let me first run it. If it throw me an error or something, because you can see the embedding nodes, it's creating the embedding nodes for you, and then it starts generating. So if you look at the generating part of it, let me make it a bit bigger so you can see it. And you can see, as I said, simple equal to more, like 0.7, it's a bit fast. Now if you make multi-context and reasoning, then it has to go through, it will create multiple context, and based out of it, it will create a lot of questions. You can see this, I don't know, let me just refresh this here. Something is wrong with, GitHub. Yeah, it's like, I don't know. But anyway, let it happen. I'll show you. Uh, I think it's probably due to size. Should I reduce it? Yeah, 150. 150 is good. Now, if you look at this, this is what I kept earlier simple 0.5 and multi-context 0.4 as a distributors. Now, if you look at this, probably, okay, it's not here. I'll show you. But this is how it creates questions, context, ground truth, and evolution type, the metadata, and everything. So you also have a ground truth. You can use the same in the Ragas evals, because Ragas has both Ragas is more qualitative evals, guys, where it looks at the faithfulness, relevancy, and those kind of things. If you want more quantitative, you have to look at the uh, bird score, mover scores, and those kind of scores to calculate it basically. You can see it says 100%, so it's done. Now I want to convert this in data frame, so let me just do test def, and in the test def I'm going to create test set dot two pandas. Yes, that's right, two pandas. And now it will create it. So let me just do test def. When you do test def, you can see the question context. I'm just going to make this a bit, convert this into an interactive table, and I'll just remove this. Now you can read it. Question: what role does BRD for recruitment play in the formation of PML, RAR alpha mediated microspeckles in acute promyelotic leukemia? And it has the context, it has the ground truth. Now, if you really want to evaluate your RAG in a better manner, you should keep multi-context and reasoning more, and keep simple as like less, like 0.3, 0.4, and multi-context a bit higher and reasoning a bit higher. So it will give you better logical questions and evals and evaluate on that. Now you can find out all the questions. You can look at this. You can look at this multi-context. It is multi-context. It says, how do racial disparities in cancer predictor docs affect immunotherapy strategies? And it is multi-context, and it also has your metadata. It has your ground truth and whatnot, right? This is fantastic, guys. I mean, I liked it. Now you can also like generate some graphs and all, if you want. It will generate some graphs. You can look at I'm using like Colab Pro, that's why I have these features. If you are probably doing it, you will not have these features. If you look at categorical distribution, it will add a new cell and you can just run it. Excuse me. Once you run it, it will probably just show you the categorical distributions, frequency, and everything. Lot of good graphs, guys. You can just have a look at that. Now, this is fantastic because you save a lot of time, and you can not only that, right, you can create question answers as well, guys, high quality questions from this technique, because a lot of you ask how to generate questions, from a set of document or a set of data. This is how you can do it. And not only straightforward questions, but multi-context based questions or reasoning, high quality reasoning that involves high quality reasoning, behind a question. So you can also do that, and I think you should try it out and let me know your feedbacks on this as well, because I think I'll be doing it for a while. Now, this is what I wanted to do in this video, guys. I wanted to show you how you can generate high quality synthetic test data for your RAG systems, for evaluating your RAG, for baselining your RAG and whatnot. I also have other videos on synthetic data generation using Gretel. Gretel is a fantastic, it's a startup by the way, but it's a fantastic framework to create synthetic data. I have through Argila, Distillable, and a lot of others, like LLM, through LLM as well. I'm going to create some videos on Nemotron soon. The notebook will be available on my GitHub repository as I was showing you. Find the link in description. And if you like the content, please hit the like icon. If you haven't subscribed the channel yet, please do subscribe the channel, guys. That motivates me to create more such videos in your future. Thank you so much for watching. See you in the next one.